Okay, in this video we're going to be looking at some proofs involving parallel lines. Now we've already done some proofs that we called algebra proofs, where we just solved algebraic equations using a particular structured format called a two-column proof. Now we're going to do the same thing using some parallel lines, some diagrams involving parallel lines, and some of the postulates that we learned involving parallel lines, in particular the corresponding angles postulate. Now we're going to start out by proving the four parallel lines theorems that we learned, and we're going to start with the proof of the alternate interior angles theorem. So the alternate interior angles theorem, remember, says that if two parallel lines are cut by a transversal, then alternate interior angles are congruent. And we're going to state that theorem in the given proof format like this. K is parallel to L. These two lines are parallel. And we're trying to prove that angle 1 is congruent to angle 8. So we want to prove that these two angles are congruent, and that will be the proof of the alternate interior angles theorem. So in order to do that, I'm going to make use of what I know about corresponding angles, and I'm going to use this pair of corresponding angles. And the corresponding angles postulate tells me that if I have two parallel lines that are cut by a transversal, these corresponding angles must be congruent. So I'm going to start with that in my proof. Actually, I guess I'm going to start with that after I start with my given statement. My given statement is line K is parallel to line L. So that's going to be statement number 1. Statement number 2, I want to note that angle 1 is congruent to angle 3. How do I know angle 1 is congruent to angle 3? I know angle 1 is congruent to angle 3 because angle 1 and angle 3 are corresponding angles, and the corresponding angles postulate tells me if two parallel lines are cut by a transversal, corresponding angles are congruent. So angle 1 and angle 3 must be congruent. Now I want to note that angle 3 and angle 8 are also congruent. Now how do I know that angle 3 is congruent to angle 8? Well, I know angle 3 is congruent to angle 8 because those two angles are vertical angles, and I have a postulate, the vertical angles postulate, that tells me vertical angles are always congruent. So now I have these two statements here, statement number 2, statement number 3. I've got angle 1 is congruent to angle 3, angle 3 is congruent to angle 8. Now I'm going to take these two statements and put them together using a particular property of congruence that I have learned. In particular, since angle 1 is congruent to angle 3 and angle 3 is congruent to angle 8, I know that angle 1 is going to be congruent to angle 8 by the transitive property of congruence. And remember, the transitive property of congruence states that if angle A is congruent to angle B and angle B is congruent to angle C, then angle A must be congruent to angle C. So now I've started with my given statement, and I've made two additional statements, and I've gotten down to my final statement, statement number 4. I've shown that angle 1 is congruent to angle 8. Thus, I have proven the alternate interior angles theorem. All right, let's take a look at the same side interior angles theorem. Remember, the same side interior angles theorem says if I have two parallel lines cut by a transversal, then same side interior angles are supplementary. So we're going to state this theorem in given proof format like this. Line K is parallel to line L. That's my given. I want to prove angle 1 is supplementary to angle 4. These are same side interior angles. Well, once again, I'm going to use my corresponding angles postulate, and I'm going to use the fact that these two corresponding angles must be congruent. Then I'm going to show that angle 3 and angle 4 must be supplementary because they are a linear pair. So let's go that far. Start with my given information. K is parallel to L. Step 2, angle 1 is congruent to angle 3. How do I know angle 1 is congruent to angle 3? Because they are corresponding angles. And my corresponding angles postulate tells me that those two angles must be congruent. Step number 3, I'm going to say that angle 3 is supplementary to angle 4. Now, how do I know that angle 3 is supplementary to angle 4? I know that because these two angles form a linear pair, and the definition of a linear pair of angles tells me that linear pair angles are adjacent and supplementary. So I know these two angles must be supplementary. Well, now, once again, I'm going to take this statement, and I'm going to put them together to make a new statement. Since angle 1 is congruent to angle 3, and since angle 3 is supplementary to angle 4, I can substitute this value, angle 1, for angle 3. Since angle 1 and angle 3 are congruent, I can substitute that. So I'm going to be able to say angle 1 is supplementary to angle 4. I've just substituted this value here, angle 1. I've substituted that for angle 3. And I know that I can do that because of the substitution property of congruence. And I've just proven that angle 1 is supplementary to angle 4, which is my proof of the same side interior angles theorem. Okay, next I want to prove the alternate exterior angles theorem. Remember, the alternate exterior angles theorem says if two parallel lines are cut by a transversal, then alternate exterior angles are congruent. And I'm going to state that theorem in the given proof format like this. K is parallel to L, that's my given. I want to prove that angle 2 is congruent to angle 7. Angle 2 and angle 7 are alternate exterior angles, and I want to prove that they are congruent. Once again, I'm going to use my corresponding angles postulate, and I'm going to use these two corresponding angles. So the format of this proof is going to look very similar to the proof that we did for example number 1. So once again, I start with my given information. K is parallel to L. Statement number 2, angle 2 is congruent to angle 4. Why? Because the corresponding angles postulate says that if two parallel lines are cut by a transversal, corresponding angles must be congruent. Step number 3, I want to say that angle 4 is congruent to angle 7. How do I know that angle 4 is congruent to angle 7? Because they are vertical angles, and the vertical angles postulate tells me that vertical angles are congruent. Now again, just like in the proof from example number 1, I've got angle 2 congruent to angle 4 congruent to angle 7, so I'm going to use these two statements and I'm going to put them together using the transitive property of congruence. Angle 2 is congruent to angle 7 by the transitive property of congruence. And I've just proven the alternate exterior angles theorem. Now finally, I want to prove the same side exterior angles theorem. And I'm going to state this theorem in given proof format. Given K is parallel to L, I want to prove angle 2 is supplementary to angle 3. So angle 2 and angle 3 are same side exterior angles, and I want to prove that they are supplementary. Once again, I'm going to use my corresponding angles postulate, and I'm going to use that with these two corresponding angles. And again, the format of this proof is going to look very similar to the proof from example number 2. So statement number 1, start with my given information. K is parallel to L. Statement number 2, I want to say angle 2 is congruent to angle 4. How do I know angle 2 is congruent to angle 4? I know they are congruent because they are corresponding angles. And the corresponding angles postulate tells me if two parallel lines are cut by a transversal, corresponding angles must be congruent. Now that I have angle 2 and angle 4 congruent, I would like to say that angle 4 is congruent, angle 4 is supplementary to angle 3. How do I know that angle 4 and angle 3 are supplementary? Well, they form a linear pair, and the definition of linear pair angles says that linear pair angles are adjacent and supplementary. So angle 4 must be supplementary to angle 3. Finally, I'm going to take these two statements, statement 2 and number 3, I'm going to put them together using the substitution property. Since angle 2 is congruent to angle 4, I can substitute this value, angle 2, for angle 4, and I have angle 2 is supplementary to angle 3, and that's by the substitution property of congruence. And angle 2 is supplementary to angle 3 is what I was attempting to prove, and I have just proven the same side exterior angles theorem. Now, it's very handy to have these theorems proved, because once we have proven these theorems, we can now use each one of these 4 theorems in additional proofs. So let's see how that's going to look. Take a look at example number 5. So here I have a quadrilateral, and I'm given that segment AB is parallel to segment CD. And I'm asked to prove that angle 1 is supplementary to angle 2. All right, well, let's see what this proof is going to look like. So let's see what my plan for my proof is going to be. I'm trying to prove that angle 1 and angle 2 are supplementary angles. Let me use one of my problem-solving tips and extend these lines out here a little bit. Well, now I've got, actually let me use my other problem-solving tip and cover up this part of my figure so that I'm just looking at this part over here. Now I can see I've got 2 parallel lines cut by a transversal, and these 2 angles here, angle 1 and angle 2, are same side interior angles. Well, something that I know about same side interior angles is if 2 parallel lines are cut by a transversal, same side interior angles are supplementary. That's the same side interior angles theorem that we just proved. Well, since we proved that theorem, we can now use that theorem as a reason in other proofs. So this proof is going to be, step 1, I start with my given information. AB is parallel to CD. That's given. Well, since AB is parallel to CD, since angle 1 and angle 2 are same side interior angles, I know angle 1 is supplementary to angle 2 because of the same side interior angles theorem that we just proved. Now you've got 2 more examples in your notes, and I want you to take a look at those and see if you can construct the proofs for those next 2 examples, and we'll take a look at those in class tomorrow.